All right, so looking down here at the middle of the page says the rule for an arithmetic sequence. So yesterday we were talking about all these sequences, and we did talk about the arithmetic ones, but we didn't have a specific formula that would really help us. And this is a very helpful formula, so you want to make sure that you have this memorized by the time we have our next quiz or test. If I want to find the nth term of an arithmetic sequence, I have to know a sub 1. A sub 1 means the first term. I also have to know what D is. D is going to be the difference. So look at this example that they gave us. They say the nth term of an arithmetic sequence with a first term of 3 and a common difference of 2 can be given by this. So they tell us that the first term, a sub 1, is 3. Common difference, D, is 2. This is going to be the formula. So we plug in 3 for a sub 1, we plug in 2 for D, and we just simplify it and we get this. All right, so let me show you a pattern now. So let's say that our first term is 5, our second term is 2, third term -1, fourth term is -4. First thing I want to do is identify whether or not it's arithmetic. If it's arithmetic, I'm going to be adding or subtracting the same amount to each term. Are we doing that? So what's D going to be? What's the difference? What am I doing to this to get to that? Subtracting 3. So D is -3. I also have to know what a sub 1 is. That means our first term. So what is our first term? 5. And so now I can come up with the formula. The rule for this sequence is going to be a sub n equals a sub 1, bless you, plus n minus 1 times D. And now I just want to simplify that. So this is 5 plus, distribute, -3n plus 3. So it's going to be a sub n equals -3n plus 8. All right. A lot of you already did this type of thing. Yeah, Tyson?
Why is the D behind the parentheses?
It doesn't have to be. You can put it in the front of the parentheses. It's just the way that they wrote the formula. So I was just doing it the same way. So a lot of you were doing this before when we had to just figure out the rule without having any formulas. And you probably would have said, okay, I'm going down by 3, so I need a -3. And then what do I have to do to -3 to get 5? I have to add 8. That's how most of you did it for last night's homework, right? So last night's we had a bunch of different types of sequences, but now we're just focusing on this type, which is arithmetic. So now I'm going to give you guys a set of numbers, and I want you to come up with the formula, with the rule. So I'm going to start with the second term. So the second term is 6, the third term is 10, fourth term's 14, fifth term's 18. See if you can come up with a rule for that. And you remember, you have to know a sub 1, so you're going to have to figure out what was a sub 1. And then once you've got it, look up here, check your answer. Did you guys get it right? Very good. All right. Now, here's how we can find the sum of a finite arithmetic series. Look at that again. Sum means adding them all up. Finite means that it stops. Arithmetic means that we're adding or subtracting the same amount. A series just means that we're adding them all, so it's just plus. Okay, so the sum of the first n terms of an arithmetic series is this formula. S of n equals n times a plus 1 plus a sub n over 2. What this means is if I have 50 terms, n would be 50, so I would put 50 in here. I'd have to know the first term and I would have to know the 50th term to use this formula. Okay, so first we're going to use it just for this little sequence that we have right here. So we're going to find the sum of these by using this formula. So here's how it would work. The sum of the first 4 terms, because I only have 4 terms, is going to be equal to n. Again, I have 4 terms. A sub 1, that's my first term, is 5, plus a sub n, that means my 4th term, which was negative 4, divided by 2. And so then I get 4 times, this is 1/2, and that answer would be 2. Now, on a problem like that, it's kind of silly to use that formula, because I can just do 5 plus 2 is 7, 7 minus 1 is 6, 6 minus 4 is 2. See what I mean? That would be a waste of time to use that formula. But think about this problem. There was a famous mathematician by the name of Carl Friedrich Gauss. He was alive from 1777 until 1855. The story goes that he was in 3rd grade, and he was one of those kids that always finished his work way before everybody else. And the teacher would be like, okay, come on, Carl, get back to work, find something to do. She just didn't know how to keep him busy. So one day she told him this. You got to remember, this is before calculators. She said, Carl, I want you to add up all the numbers from 1 to 100. So at first he's sitting there, he's like, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, doing it that way. Then he's like, hey, I got it. So he comes back about 30 seconds later and says the answer is 5,050. And the teacher's like, oh, I don't know, maybe you're right. You know, she just was like trying to keep him busy. And so he actually came up with this formula right here that we need to memorize on his own in 3rd grade, is how the story goes. Yes. Here's what he noticed, and I bet once I show you what he figured out, you're going to understand how he did it. He was going 1 plus 2 plus 3 at first, but then he looked at the end of his numbers, and he said, okay, it's going to end 98, 99, and 100, right? So what is 1 plus 100? What's 2 plus 99? What's 3 plus 98? And in the middle, he would have 50 plus 51. And what do those add up to equal? So how many 101s would he end up having then? 50, right? So he did 101 times 50. And he said, oh, okay, I know that. That's 5,050. And that's why he got that answer so quickly. So look at what he did. Do you see what he did? What did he add together? The first and the last. So he did the first plus the last. And then how many total terms did he have? 100. And what did he do to the 100? Divided it by 2, right? See, I don't like necessarily the way they write it, because the way Gauss did it was he did n over 2. It's the same thing, but he thought of it this way. He was thinking, if I add the first one and the last one together, I get a certain answer. And then however many of these numbers I have, if I just divide it by 2, that's how many of those we're going to have. See what I mean? That will help you to memorize that formula. To think of Gauss, like what did he do? He added the first and the last, and then he took 100 and divided it by 2. See what I mean? Like, I have this memorized. I hardly ever use it. You know, it's not like I use it on a daily basis, but this is easy to memorize just by thinking of what Gauss did. Okay? All right, let's practice some problems now. Flip over. So one important thing we have to be able to do is to tell whether the sequence is arithmetic. Remember, we have to be adding or subtracting the same amount every single time. So let's look at this one. We add 3, we add 3, oops, we add 5. So is it arithmetic? No. On this one, minus 3, minus 3, minus 3, minus 3. Is it arithmetic? Yes. And in fact, if I asked you, you would have to know a sub 1 is 26, and you'd have to know d is negative 3 on that. On this one, is it arithmetic? Okay, Hunter, what is a sub 1? And what is d? Good. The next one's a bit of a trick question. My last class, everybody said yes, but I'm just going to tell you guys it's no. Why? What do you think the confusion is to it? Why would people say yes when it's really no? Handa? Yeah, you're only adding 2 in the denominator. It's not that d is really 2, though. I'm not adding 2 to this whole thing to get 1/4, am I? And then they said, yeah, but what about if you just subtract a half? What's a half minus a half? 0. It's not 1/4, is it? Okay, so this looks like it might be arithmetic, but it's really not. In fact, this would have this rule. It would be a sub n equals 1 over what? Yeah, Alex? 2n. Alex is our expert with this. Very nice. All right. Let's go down to the next part. Write a rule for the nth term of the sequence, and then find a sub 20. So we could do these problems, guys, the way we used to do them before we knew that formula, but we might as well use the formula now. The formula is a sub n equals a sub 1 plus n minus 1 times d, as long as it's arithmetic. So I'm going to check this. I got to make sure it's arithmetic. 6, 6, yep, we're adding 6 every time. So then my rule is going to be a sub n equals my first term plus n minus 1, and my d value is 6. So it's 3 plus 6n minus 6, which is 6n minus 3. Pretty easy, right? All right, let's do a harder one. Let's do number 7 together. Check to see if it's arithmetic. Okay, people are saying yes. Tyson, what is D? Good, we're actually adding 1/2, so it's going to be positive. Our a sub 1 value is negative 1. So now we can plug it into our formula. A sub 1 plus n minus 1 times d. So we're going to have negative 1 plus 1/2 n minus 1/2. Oh, I forgot to find a sub 20. We'll go back and do that. So then a sub n equals 1/2 n minus 3/2. So back here, they asked me to find a sub 20, meaning the 20th term. So I would do 6 times 20 minus 3, that's 117. For this one, I'd have to do a sub 20 is 1/2 times 20 minus 1/2. So that's 10 minus 1/2. Well, 10 minus 1 is 9, minus another half is 8.5. Okay? All right, let's come over here now to the other stuff. Okay, write a rule for the nth term of the sequence where a sub 12 equals negative 13 and d equals negative 2. Then graph the first 6 terms of the sequence. Okay, so they're telling us it's arithmetic because they told us what d is. It means it has to be arithmetic. But the problem here is they didn't tell us a sub 1, and we have to figure out what a sub 1 is. I could sit here and think backwards and figure out a sub 1. It takes too long, though. Here's what I'm going to do. I know for this, n equals 12, right? So I'm going to set it up. A sub n equals a sub 1 plus n minus 1 times d. I want to know what is a sub 1. So I need to know everything else. Well, I'm letting n be 12. So what is a sub 12? What was I told that answer is? So I have to put in negative 13 here. A sub 1, I don't know. I know the 12th term, so I know what n is. And they told me what d is. So by knowing all this other stuff, I can figure out what a sub 1 is. So negative 13 equals a sub 1 plus 11 times negative 2 is negative 22. Add 22, and you get 9. So now I know my first term. And it asked me to graph the first 6 terms. Well, now that I know my first term, I can easily find my other ones. I know I'm just going to subtract 2 every time. I don't need to use the formula for that. See, don't always use your formula unless it's really necessary. So now I'm going to graph these points. I've got 1, 9. I've got 2, 7. I've got 3, 5. 4, 3. 5, 1. And 6, negative 1. And so what kind of shape do I get here? What's this going to be if I connect all these dots? What kind of function is it? It's linear, isn't it? So that's a linear function. Now, I might want to go ahead and find my actual rule. A sub n equals a sub 1 plus n minus 1 times d. So it's going to be 9 minus 2n plus 2. So it's negative 2n plus 11. See what I did there? And doesn't that make sense that if I just kept going that my intercept would be 11? That's my y-intercept. All right, so this is going to be similar. It says in exercises 10 and 11, write a rule for the nth term of the sequence. They tell us our 8th term and our 13th term. Can you think of how we can find d? You know?
Since it's going to be constant, we can subtract the 8, 13, the 88, the 8, 15, and then subtract 99, plus 59, 45, 50.
Yep, he's right. Here's what's going on, guys. Our 8th term is 59. Our 9th term we don't know. 10 we don't know. 11, 12, 13th term we do know, right? So this is our 8th, 9th, 10th, 11th, 12th, 13th. So I want to know what's the difference between these two. So 99 minus 59. Well, that gives us 40. And then we think, well, how many spots was that? 1, 2, 3, 4, 5. Divided by 5 intervals. And that gives us 8. And so D is 8. We can do it much faster. 99 minus 59 over 13 minus 8. It's just like finding slope. You're trying to find what's the difference, what's the rate of change. So now I can find my rule. A sub n equals a sub 1 plus n minus 1 times d. But I have a bit of a problem. What's the problem? I don't know a sub 1, do I? So to find a sub 1, I can count backwards if I want. I can just go down by 8 that many times and I can figure it out. Or I could use another formula. I can say, I know that this one right here. So I could say 59 equals a sub 1, I don't know. But I do know that when n is 8, a sub n is 59. So I can do this. And I know what d is. And so a sub 1, that's 56. So a sub 1 would have to be 3. So now I can get my formula. Okay, makes sense? All right, so just real quick, how would we find D here? Evan, can you tell me how I'd find D?
You do A27 minus A18, which is A sub 9. Then you do negative 8 minus.
You're doing it upside down. You're going to have to do negative 8 minus negative 5 over 27 minus 18. Okay? Because you have to do the y values divided by the x's. It's just like slope. So these are the outputs, the y's, and these are the inputs, the n's. Okay? So d would end up being, what is that, -3/9, so -1/3, and then you have to go from there. All right, last one here, find the sum. We're going to use that sum formula that Gauss came up with. This is the one, S sub n equals a sub 1 plus a sub n times n over 2. That's the way I think of it. Our book does it a little differently, but it's all the same. So I have to find the sum of my first 22 terms. So I have to know my first term. So I have to plug in 1 to this. 5 minus 2. So a sub 1 is going to be 5 minus 2 times 1, which is 3. Then I also have to find my nth term. Well, n is 22. So a of 22 is going to be 5 minus 2 times 22. 5 minus 44 is -39. And then I have to do times 22 over 2, which is 11. So that's going to give me -36 times 11. Get out our calculator. And we get -396. Now, we don't really have to use that formula because remember, you can use your summation too. I think I did a summation recently. There we go. Oops, that's actually the exact same problem. So what I can do is I can use any variable I want. I don't have to use the letter I. I used x, and I just went from x equals 1 to 22, put it in there, and there's the answer, same thing. All right, pretty easy stuff. Okay, you've got your assignment on the board. It's also on your yellow sheet that I